Let's take a look at another example of how we can sketch a graph of a quadratic function. This one says sketch the graph of y equals negative 1/2 x squared minus x plus 1. Keeping in mind, this is y equals ax squared plus bx plus c. Now, just looking at our leading coefficient right here, I'm expecting my graph to open down because this is negative. Remember, our leading coefficient tells us whether the graph will be opening up or opening down. If it's negative, it opens down. So that should have an idea, give me an idea of what my graph should look like. Remember, our steps to graphing, the first thing we need to do is find the x-coordinate of the vertex. We do that by using negative b over 2a. So we have negative. Now be careful here. This becomes plus a negative 1x. Just because it's minus up here doesn't mean we can forget, because our quadratic function, our quadratic equation here is plus. So we have negative negative 1 over 2 times my a, and a is a negative 1/2. So simplifying that, we get 1 over a negative 1, which ends up being negative 1. So the x-coordinate of our vertex is negative 1. Now make your input-output table. Negative 1 we're going to put in the middle, because that's our vertex, and then we want to have a couple to each side. You pick the ones on either side. I'm going to use negative 3 and negative 2, 0, 2. I pick those. You could pick different ones, but again, you don't want to stray too far from your x-coordinate of your vertex. So up here, I'm going to just substitute in negative 1/2 times negative 3 in parentheses to keep it as a negative 3 squared, either plus a negative 1x or minus my negative 3 plus 1. And when I do that, I get a negative 0.5. And I'll do the same thing. Negative 1/2 times negative 2 squared minus my negative 2 plus 1. And I get 1. I'll put a negative 1 in, and I end up with 1.5. If I input a 0, I get out 1. If I input a 2, I get out negative 3. Okay, so again, just creating an input-output table, being careful to type things correctly into my function. Then we just have to plot the points. So on my graph here, I have negative 3, negative 0.5, negative 2, 1, negative 1, 1.5, 0, 1, and 2, negative 3. Okay, so you can kind of see what our graph should look like here. And again, the tricky part is, oh, I was so close, is connecting with a smooth curve. Okay, and kind of extending it, as always, in both directions using arrows. Now, does that graph make sense to me? Remember, I said because my leading coefficient was negative, that it should be a parabola opening down. Okay, and so that makes sense. We found our x, our negative b over 2a, our x value of our vertex to be negative 1. So our line of symmetry should be through x equals negative 1, and it is. Right here. Especially if I could draw a nice smooth curve, we would see that it would fold in half at that point. Okay, so again, to graph, you get to find the x-coordinate of your vertex using negative b over 2a, make an input-output table with values on each side of your x-coordinate, and then draw a smooth curve. Let's look at another example. It says a struck baseball follows a path modeled by y equals negative 0.00993 x squared plus 1.1106x plus 4.1, where x is the horizontal distance and y is the height. So it says to the nearest foot, what is the maximum height of the baseball? Now think about that. If we're talking about the maximum height, this parabola, since this is negative, is going to open down. So the maximum height is going to occur at the vertex. Okay, so our parabola is going like that. The maximum height is going to occur at the vertex. Now, we can figure out the vertex using negative b over 2a. So if I plug that in here, I have my negative b, 1.1106, over 2 times my a, which is a negative 0.00993. If I divide that out, I get approximately equal to 56, but that's not our answer. Remember, x represents our horizontal distance. So what this is telling me is that at the vertex, we're horizontally over here to 56. So at 56 feet, it reaches its maximum distance. They want the maximum height. Not hard to figure out though, guys. Take your 56 and then just plug it in here for x. So if I just plug in 56 in for x in both of these, I would see that my maximum height, or my y distance, would approximately be equal to 35 feet. It's going to occur 56 feet away from where I threw it, but the height is going to be 35 feet. You can kind of say that the vertex here occurs at 56:35 if you want to think of it that way. Now the second question says, how far to the nearest foot does the ball travel before hitting the ground? So we're over, and I didn't make a very good graph here. Let me maybe fix it, because obviously that should come there. If we're standing here and we throw this ball, we want to know, when is it going to hit the ground? Well, obviously it's going to hit the ground where our y value is 0. If you have a graphing calculator, that is going to be a very important tool to be using. And I will show you in class how to type it in and how to graph on here, because you're going to want to be able to do that. For now, I'm just going to show you an online graphing calculator. On this online graphing calculator, I graphed the equation it gave us, and it's showing us the flight of the ball. Now keep in mind, this is not thinking in terms of it being a baseball. Otherwise, it wouldn't make sense for us to have these negative values. But what it's showing us is, if we're standing right here, the flight the ball is taking. So if we trace it, you can see where the ball is. So after 16 feet, it's about 19 feet high. Remember, we said it might have reached its maximum distance at about 55, so that would be between these two. And remember, we said it was at about 35, so that makes sense. But right now we're interested in when it's going to hit the ground. How far out are we throwing that baseball? And if you look right here, notice it's jumping from the negative to the positive. Actually, that's pretty close, 0.26. It's hitting the ground at 0, and this is pretty close. Notice that my x value is 115. What that tells us is, it says, how far to the nearest foot does the ball travel before hitting the ground? That's approximately 115 feet. Okay, according to our graph, when we threw it, it hits the ground at 115. And that's why a graphing calculator can be very useful. And I'll show you how to use that, how to use your graphing calculator in class. And if you don't have one, I'll show you where to go to get an online graphing calculator. Okay, so this is just a real life example of how whenever we throw a baseball or we throw a football or anything like that, it's following a quadratic path, meaning it's a parabola. It goes up and it comes down. Even if you have a really good arm, there's going to be a slight variance. It's going to go up a little bit.